Hello friends, today we will see about alignment, measurement and correction. Okay, so before that let us understand what is alignment. So alignment means what? It is the misalignment of rail with respect to center of track. With respect to center of track, both rail to be straight. See, let us say this is the center portion and this is the track, right? So both the track, this one and this one, should be straight with respect to this. That's what they are saying. So this is a straight track, but suppose any deviation is there like this or like this, then it is a aligned track. If you see this picture, see in this, here this rail and this rail are straight with respect to center, but if you see here, with respect to center, this rail has some bent outside and this rail has got bent inside. So this is called alignment, right? So this rail is aligned outside with respect to center. This portion of rail is aligned inside with respect to center. So this is a aligned track, this is a straight track. Okay, this is a straight track and this is a aligned track, right? So now question is how to measure this alignment. First we will measure it and we'll get magnitude. After that we will correct it. So let us understand how to measure the alignment. So what we have to do, see this picture. So if you see this picture here, so from long distance, approximately 3 to 4 rail length, 30 meters to 60 meters distance, you sight the track. You sight the track, you will observe a deviation like this. See, you have seen some deviation outside like this and like this, and you can also observe this portion. So where this portion was started, you can see, and you can also see the straight portion, right? Now what you have to do, you have to, okay, hold a cord from straight portion to straight portion. Okay, from straight portion to straight portion you have to hold a cord. And now what is the distance from this cord? Okay, what is the distance from this cord to, let me change the color. So what is the distance from this cord? See, so distance from this cord to the rail, that is called alignment, right? So that is called alignment. Now what you will do, at every 3 meters, so here both rail and cord was coinciding. Here from cord rail was 5 mm distance. So here, right? Again at center you have 20 mm distance. So this distance is what? 20 mm. And here 10 mm, 5 mm, 0 mm. So right now you got, if you have a track like this, right, you got the distance, okay, central distance, and you also got distance at every 3 meters. What should be the gap, right, like this. So this measurement you have with you, right? Now next you have to do correction. So before correction, you got what is the maximum value of slew. This is also called slew or alignment. What is the maximum value of alignment? And you also got alignment values at every 3 meters distance, right? Now we go to the next step. Now you have measured the alignment values. Now you will go for correction, right? So for correction, just like unevenness, see, if that magnitude is very small, suppose like 10 mm, 5 mm highest value is very small. So you have a track like this, and this is the alignment value, right? So if this magnitude is very small, right, you can directly start correcting whether train comes or not. Or if you got some block, right, then also you can do alignment correction directly from one end to another end. Or if you have got sufficient time to complete this work, then also you can do alignment correction directly, right? So you need not do in a stage wise manner, right? You can do it directly under this condition from here to here, right? But if magnitude is very high, you don't have any block, you should pass the train. Under such situation, it is better to do stage wise correction of alignment. We'll understand this here. See here, okay? So now let us understand how to correct under direct condition. So what you have to do, now you have the alignment like this, right? Now you have to make it straight. This should go inside, this should go inside, this should go inside, okay? So this should come here, this should come here. So how much you have to move it, that we already know. So here this should go in this direction by 20 mm. Here you have the reading. So here it is 5 mm. So what you do, you push the track by 5 mm, you push the track by 20 mm. You start from one end you start it. Here you apply a force and this will come here like this. You apply a force and you will come here like this, right? Understood or not? So up to here it is clear. So direct way you can do it, but stage wise, if you see here, stage wise correction. So when we have to go for this, when you do not have any block, if magnitude is very high, 40 mm, 50 mm like that, or you should pass the train. So in that condition, so you should bring this black color to green color. You should make from here to here, okay? So for that, what you will do, in direct way you will directly go from one to here, but in stage wise, first we go from here to here, right? Next from here you will go to this blue color, and then finally we will go here, right? So that's how we will do stage wise correction, right? Suppose you got a magnitude of 40. Suppose let us say you have a track like this and you want to do correction in a stage wise manner. What you have to do, so let us say 40 is very high value, right? First what we will do, we will correct up to 20, right? We will correct up to 20. So what I will do, 0, 5, 10, 15, 20, then again 15, 10, 5, 0, right? Now further, if I want to go again, so again what I will do, I will start giving 0, 5, 10, 15, 20, 15, okay, 10, 5, 0. Now the overall correction has become how much? 40. So to understand clearly what we are doing, in stage wise 40 was corrected 20 plus 20 two times. Okay, in direct way you are directly giving a movement of 40 mm, right? Understood or not? But see, when train comes, your track will be like this. In direct way you have moved some portion like this. So this kind of situation is very dangerous, and this direct way should be done only under block, or you have sufficient time, or magnitude is very less, right? Understood or not? So up to here it is clear. So practically if you see what we will do, how we will correct. So first see, let us say this is the alignment, your track has gone. Let us say this much track has moved out and this track will come inside like this. Now what you have to do, so you have to apply a force from inside, like this. So for that you will make some hole here, and after two slipper you will make one more hole here, after again two slipper you will make hole here, and so on like this, right? Next you will fix the jack and you will apply a force in this direction until you move this track by 5 mm. Then here again you will fix the jack, apply a force, okay, until you move the track by 10 mm, like that you so on cutting, right? After that, once your track becomes straight, here at slipper end you will have gaps, and that has to be properly packed and filled with ballast. That's how you will do packing, right? So see, you will apply the force, you will make holes, then leave the two gaps, and then apply, make a hole to support the track, make a hole. Now you will fix the jack and apply a force here, fix the jack and apply a force here. So that's how you will correct it, right? Once suppose your track was like this, after pushing it will become like this, and initially if your track was like this, after pushing it will become like this, right? So that's how alignment was corrected. Alignment is also called slew, right? So if you do manually you have to make the hole and you have to fix it, but if you do machine tamping, then if you simply give these values, if you simply mark these values, they automatically set the track. Okay, thank you, thank you so much friends, thank you for watching this.